Alright guys, what's up? We're going through the review sheet here. So first question, what are the factors? Remember, when we're doing factoring, we're looking first for GCF. So x squared, 5x, and 6, right? They don't have anything in common. Okay. 3 terms means we're doing trinomial. So I drew my diamond. A times c on the top. So that's 6. Okay. And then our b term is on the bottom. And that's -5. So we're looking for 2 numbers that multiply to 6 and then add or subtract to give me -5. So that's -2 and -3. And then I do my 2 parentheses. So x, and then we put the -2 in there. And then x, and then the -3. So x minus 3. And there are 2 factors. All right. Okay, which equation has factors of 3 and -5? So you can kind of think of it as though we're putting in the 3 and -5 here. So when I multiply 3 times -5, I get -15. And when I add them together, I get -2. So this number has to be in the middle, the -2. And then this number is on the end, the 15. And so it should be this guy. And if we factor it, x plus 3 and x minus 5 should work. Your other option is also to distribute and multiply. So if you did x times x, that would give you x squared, right, minus 5x, and then put the 3 through, that's plus 3x, and then minus 15. And then these 2 terms are going to add to give you the -2. Number 3. Okay, graphed on the axis below, parabola, what is the vertex and axis of symmetry? So the axis of symmetry equation is x equals -b over 2a. So here, a is the number in front of the x squared, so that's 1. B is the number in front of the x, which is 3. And c is the number, the constant number, just the number on the end. And that is -18. Okay, so this is 3, and then c is -18. So if we plug into our formula, do -b over 2a, we're going to get negative of 3 over 2 times 1, and that's going to be -1.5. So that's the axis of symmetry. So if I drew a line going down, right, and then -1.5, that is not what we wanted there. All right. That would be the axis of symmetry. Okay. So remember, it's a line. That's my equation. X equals -0.5 or -1/2. Sorry, it's -1.5. Okay. And then the vertex is the point at the bottom down there. And what we want to do is just plug that -1.5 in. Now, if we do a graph, we can do that real quick. Okay. So it's x squared, and then it was plus 3x minus 18. By the way, if you hold Alt and press Tab, that lets you switch between windows on the computer. All right, and we want to do menu, analyze graph, and this time it's a minimum because it's concave up, and we can get our point. So we know that that's our vertex, and that x coordinate, that -1.5, is the axis of symmetry. So if I were to plug in, okay, and do y equals -1.5 squared, okay, plus 3 times 1.5 minus 18, this is going to equal -20.3. So my vertex is -1.5, -20.3. Pretty kid in the background there. Okay. What's the vertex and axis of symmetry of the parabola below? So same thing, x squared minus 16x. So tab, go up and edit this. So x squared plus 16x minus, and we got that wrong, it's minus 16x plus 63. There's our graph here, okay? And we want to know the vertex and the axis of symmetry. So we're going to go menu, analyze graph. It's a minimum again. And I think I pressed the button I wasn't supposed to. So click, drag, click, and there's our minimum. So it's 8, -1. All right, is the vertex, and the axis of symmetry is going to be x equals 8. So 8, -1, okay, and x equals 8. All right, which expression is equivalent to? So once again, 3 terms. We're looking for a GCF first and nothing in common. So we're going to draw our diamond. We're multiplying 1 in the front times 36, which is 36. And it adds or subtracts to give you -12. So that's -6 and then -6. All right, and then this is x to the 4th here. So if we wanted to get x to the 4th, we'd have to do x squared times x squared. So instead of being x's in the front, we know it's going to be x squared in the front. All right, and then I'm just going to take these two numbers and put them in. So it should be -6 and then -6. Another way to write that, by the way, is to do quantity squared, and we'll talk about that a little bit later so that we know that our answer here is number 1. All right, there's our first page. Going on to page 2 here, some factoring. We'll get to that graph in a second. So, first thing I'm always looking for, right? Number 1, always looking for a GCF first. Okay? Then I'm going to ask myself, how many terms? Okay? If there's 2, we're doing perfect squares. Okay? And if there's 3, then we're doing our diamond and the trinomial. All right? So, looking through this first one, there's no x's in common, and there's 3 doesn't divide into 10, so there's no GCF. So I do a times c first, which is -30. And I want to add or subtract to give me 13. So the factors of 30, 1 and 30, 2, 15, 3, 10, and then 5 and 6. My x factor is 6, we already have it, so we're done. The only way to get 13 is to use this, which is 2 and 15. And I need the 2 to be negative in order for this to work. Because there's a 3 in front, I know I have to use the box here. Okay, so that's 3x squared and -10. And I'm going to drop the 2 and the 15 in here. So -2x and 5x. And then we're going to do our GCF. So going across from left to right here, we have the 3x squared and 2x. We just have an x in common. The 5 and 10 have a positive 5 in common because the first term is positive. And then going down, the 3x and the x squared and the 5x have an x in common. Oh, this should be a 15. So they have a 3x in common. There we go. I was wondering why that wasn't working. And then the -2 and the -10, because it starts with a negative, it's a minus, and they have a 2 in common. And so my 2 factors are then x plus 5 times 3x minus 2. All right, second one. So this is no GCF again, but it has 3 terms, so we're using trinomial. So I do my diamond, multiply to give me -36, add subtract to give me 5. So the factors of 36, 1 and 36, 2 and 18, 3 and 12, okay, 4 and 9, and then 6 and 6. And the only way to get 5 is to use the 4 and the 9, and I need it to be negative. So I know it's a -9, +4, and then I do my 2 parentheses, x and x in the front, and then I'm dropping the 9, the -9, so -9, and the +4 for +4. Okay, now letter C here. Checking for GCF first, and there is a GCF here, right? The GCF is 2. So I'm going to first factor out a 2, so 2 goes in front, and then I'm dividing in. So 2 goes into 2x squared, leaving me an x squared left over. 2 goes into 12x, leaving me a 6 and the x left over. And 2 goes into 16, leaving me the 8 left over. This term can still be factored, right? It is a trinomial now, and I need to multiply to 8 and add to 6. So 8, 2 and 4, and 1 and 8. And the only way to get 6 is to use the 2 and the 4. So the 2 has to stay with this, because I have to be able to get back to the original here. So that 2 is going to stay, and then it's x and x for x squared, and then positive 2 and positive 4. All right, letter D. Once again, looking for a GCF. Nothing here again, okay? So I do my trinomial. 3 times 10 is 30, and I need to add a 17. So once again, we know from earlier that 30 has 1 and 32 and 15, 3 and 10. The only way to get 17 is to use the 2 and the 15. And so I'm going to put my parentheses down. Actually, I'm not. Because this starts with a number other than 1, right? There's a number in front of the t squared. I have to use the box now. So, as we wait for... Okay. All right. So I drop the 10 t squared in and the 3. And then I'm bringing in the 2t and the 15t. Remember, use the same letter that shows up in the problem here, okay? All right, GCFs, from left to right. The 10t squared and 2t have a 2t in common. The 15t and the 3 have a positive 3 in common. Going down, the 10t squared and the 15 have a 5t in common. And the 2t and 3 don't have anything in common, so we're going to take out a positive 1. Remember, we're starting with a positive, so that's why it's a positive sign here. Okay? All right, and there's our two factors. So 2t plus 3, and then 5t plus 1. All right. Dropping down, letter E. First thing we check for is a GCF, and there is. They have a 6 in common, so we take the 6 out, and we get left with z squared minus 4. And then we're checking to see if it factors again. And this does indeed factor. They're both perfect squares, and there's a minus sign. So this is going to be a z and a 2 with a plus, and then it repeats, but this time there's a minus sign. All right, just to be consistent. Well, we'll just go back to where he was. All right, and then the last one is the x squared minus 16. So once again, no GCF, 2 terms, so it's perfect squares. Okay. So the square root of x to the 4th is x squared, and then the square root of 16 is 4. So we're dropping those in the front, so x squared in the front, right? 1 plus, 1 minus, and then 4 goes in the back. Now, we want to ask, can we still factor, right? This is not going to factor, it stays the same. This, however, will factor, okay? So this just becomes the same thing, and we can't factor it because it's a plus, not a minus. It's not a difference, okay? And then the square root of x squared is x, the square root of 4 is 2, so this factors into x is in front, 1 plus, 1 minus, and then 2's in the back. All right? On to the next one. Okay, graphing. Remember the tip on the top here, right? If it's an interval, they tell you what x values to use. No arrowheads, okay? We're going to use endpoints. So for a -1 and -5, we use endpoints at those values, okay? So our graph is just going to stop and curve and stop there. Now, obviously, we're not graphing those, but there you go. So the first thing we're going to do is find the axis of symmetry, okay? You remember, it's x equals -b over 2a. So here a is 3, and b is 3. So x is equal to -3 over 2 times 3, which is essentially -3 over 6, which is -1/2. So I'm going to make an xy table, and I know I have to put -1/2 in the middle. What I need to do is figure out the y value. So our options are, and the easiest way to do it is to use a calculator here, okay? So I grab my calculator. At this point, if I'm doing a test, I'm opening a new document here, okay? Graph. So 3x squared plus 3x minus 6. There's my graph, okay? We need to find the axis of symmetry, or the vertex. So analyze graph. We know it's a minimum because it's concave up here, okay? So I pick my window, and there's my minimum, okay? So I know that when x is negative 0.5, the y value is right there, is negative 6.75. So I go back to my table, and I put negative 6.75 here. All right, I'm going to go back to my calculator. I'm going to go to the table. I'm going to get that negative 0.5 to be in the middle, and we can see right here, we got 6, 6, negative 6, negative 6, 0, 0, so there's my middle. And then I'm going to record these other values here, okay? So we got negative 1. So the next number after negative 0.5, next whole number is negative 1. And then negative 2. Remember, don't use decimals, use whole numbers here. The next largest number, the bigger number after negative 0.5 is 0. And then 1. And so you know this is negative 6, so this is negative 6. And if this is 0, then that's 0. So we have that symmetry going on here, okay? All right, we're going to graph those points. So negative 2, 0 is right there. All right. Okay, negative 1 is negative 6. 1, 2, 3, 4, 5, 6. The next one is negative 6.75. So somewhere in between these two values, where negative 6 and negative 7 go, is where we're going to put those down. All right, so somewhere right about, oh, that's a little too much there. So right about there. Okay, at 0, it's at negative 6, and then we're going to go back up here. All right, now the next one's up at 12, so it's somewhere over here. It's off the graph. We're not going to graph that point. What we want to make sure we do when we draw this is as we draw this curve in, we want to make sure that we end up pointing in that direction, okay? We don't want to cross too far this way, so it goes off, and we don't want to curve back in that way, okay? So we want to make sure our graph ends somewhere in between 2 and 3 there. All right, yeah. So then the next one, I'm already off. Rewind, don't do that. Look what I did. We're supposed to be at negative 0.5 for the vertex, and I graphed it at 0. So, my bad. That should definitely not be there. All right. So, this should be there. Okay. That's going to be 0, negative 6. Hopefully you caught that while I was doing it and was like, what is he doing? All right, and then 1, 0. All right. Okay, so we draw our graph up from here. And same thing though, we want to end up somewhere in between, heading in that direction. And then somewhere in between, heading in that direction, okay? So it doesn't have to be a perfect graph. You might see like this side didn't go right through that point, so we want to be pretty close. Okay, there's my graph. We can label it y equals 3x squared plus 3x minus 6. Okay, the axis of symmetry, if it asked us to draw it, okay, we're going to go straight down through this negative 0.5 right there. That's the axis of symmetry. Let's give it a different color. Let's go. We'll go pink here, I guess. All right. So there's our axis of symmetry. The equation is x equals negative 0.5. And there's our vertex, okay? And there's the coordinates of that vertex right there. All right. Second graph. Y equals x squared minus 7x plus 8. So x squared minus 7x plus 8. And it broke. Alright, and oh, look at that. The vertex stayed with it. Let's delete that point though. Actually, we're going to go new document. Not what we wanted. X squared minus 7x plus 8. Alright, there we go. So once again, keystrokes, menu, analyze graph, minimum again, select, drag, there we go. Okay, there's our vertex. Alright, if we're doing it by hand though, which we can go through and do. Alright, so x is equal to negative b over 2a. So negative of negative 7, which is really a positive 7, over 2 times 1. So that's 7 over 2, and there's 3.5. So on my XY chart, we're doing 3.5 in the middle. The next lowest number is 3, and then not 4, smaller people. So once again, 3, and then 2. The bigger is 4, and then 5. Going back to the calculator, I'm going to grab the table. Okay, so we can see 3 is negative 4, 2 is negative 2. So we can go back here. This is negative 2. So this is negative 2. This is negative 4. That's negative 4. Remember, the vertex was negative 4.25. So negative 4.25. Okay, so now I go graph. So 2, negative 2, 3, negative 4. The next one is a half, and it's not all the way down. It's 4.25, so it's a little bit closer. Okay, and then we head back up. Now, I have room. So I know there's probably another point somewhere up here. So what I want to do is I actually want to go back to the table and go see what the next point is. And I can see that after negative 2, it goes to 2, and then it actually goes to 8. So I might be able to fit another point here, okay? So I know if I go to 6, don't want that big guy. If I go to 6, then that point is 2. So, all right, so 6 is at, right, 2. So I know that I can next find the other point there. So 2 there, and also on the other side. And now I can better draw the graph in, okay? And I know it's going to head up to 8, so it's going to cross through somewhere over here. It's not the greatest drawing with the stylus here, but you get the idea. All right. And then we get our equation, y equals x squared minus 7x plus 8, okay? Plus, we have our axis of symmetry, which is cutting down through 3.5 right there. All right, so if we need to, we can graph that. All right. And it's an x equals, and we're good to go. And then our vertex, there's the coordinate right there. All right, last one. So Sierra tossed the ball up in the air. So we got Sierra. We talked about this in class today. Right, kicks, tosses the ball up in the air. There's the path that it takes. Okay, until it lands back on the ground. All right, so when is it at its highest? Remember, it's at the highest point at the vertex, at the turning point right there, okay? So what we need to do is figure out what the x value is, and that is referred to once again as the axis of symmetry, okay? So that's what we're going to be looking for. So for the x value, we're going to do that negative b over 2a again. Okay. So negative b, now it's, if you're looking, maybe we can see this. It's 6 and a is negative 1. So b is equal to negative 6 over 2 times negative 1. So this is going to be negative 6 over negative 2, which is equal to positive 3. So when is x the highest? It's at 3 seconds. Okay, and then the maximum value we want to plug in. So we want to know the y value if we plug in 3 for x squared. Now, because this negative's in front, we're actually going to square it, and then we're going to make it negative plus 6x. And instead of x, we're going to plug 3 in here. Okay, so this is equal to negative 3 squared is 9 plus 18, and so this value is actually equal to 9. So the maximum height of the ball is 9, and it takes 3 seconds to get there. All right. So I would probably want to reaches its all right, and then going down, we get a product question, so we're multiplying, and this is just these two. So if we're multiplying, okay, I'm taking 2x plus 3, and I'm multiplying that times 4x squared minus 5x plus 6. So I'm just going to distribute the 2x to all three terms. So 2x plus 3, I'm just going to move this over a little bit. So we got some room. All right. And then, so 2x times 4x squared. 2 times 4 is 8. And this is x to the first power. So we add the exponents. That becomes x cubed. So 2x times negative 5x squared. 2 times negative 5 is negative 10. And x times x is x squared. And then 2x times 6 is plus 12x. Then we're going to distribute the second one, which is the 3. I'm going to rainbow that in. So 3 times 4x squared is 12x squared again. 3 times negative 5x is negative 15x. And then 3 times 6 is 18. And then we're going to look for our like terms. So keep in mind here, okay? We have, this is the only one that's cubed, okay? We have 2 terms that have x squared on them, all right? We have 2 terms that have x, and then we have 18 by itself. So in standard form, the biggest exponent goes first, okay? Then we combine the 10x squared negative and the positive 12x squared, so that's positive 2x squared. Then the positive 12x and the negative 15x, that's minus 3x. And then we just have the 18 left over on the end. Okay, that's it. Length and width of the rectangle. So we're just gonna, the area, remember, is length times width, okay? So length times width. So I'm just gonna plug that in. So this is 3x plus 1 times 5x minus 6. And so we're gonna do the same thing here, okay? We're gonna distribute the 3x first. So 3x times 5x, 3 times 5 is 15, and x times x, add the exponents. They're both 1 right now, so that's x squared, okay? And then we do 3x times 6, negative 6. So that's negative, and then 3 times 6 is 18, and there's an x left over, okay? Then we're going to take the 1, and this doesn't really change anything. 1 times 5x is just positive 5x. And 1 times negative 6 is minus 6. All right. So we combine like terms. The like terms we have here are the x's. So standard form gives us 15x squared. We add, so that means we're going to get a negative because the larger number is negative, and then it's 13x, and then minus 6. And there's the area represented in standard form. Area. And that's it. All right, guys. I'll see you guys tomorrow. Happy Friday Eve, and good luck to my chess tomorrow, guys.